Adamo from the Targeted Operations team here at TrustedSec. In this video, we are going to go over some common attacks we do, as well as common configurations we see on our engagements. I'm going to go over how to abuse them, but the main focus is to show defenders how to apply the appropriate mitigations. That way, defenders can understand how the attacks are performed and how to stop them. Thank you for watching. In this video, we will go over some common attacks we see during our engagements, as well as go over the proper countermeasures. We got some interesting topics to cover, so we are going to start off by looking at the dangers of sharing a local administrator password across systems, and then we are going to go over how to implement the local administrator password solution as a mitigation. Then we will go over what sort of attack surfaces that exists when SMB signing is not set to required, and how we can configure this in a group policy to mitigate the abuse. The printer bug is also a common attack that we see a lot, and we're going to look more into this, as well as how to disable the print spooler through group policy to prevent abuse. And lastly, we are going to look at how NBNS and LLMNR broadcasts are abused, and how we can mitigate that as well. Shared local administrator passwords. These are often found in deployment solutions where they deploy Windows and they set the same password on each system. This is an advantage for admins because they can use the same credentials to log into various servers' machine when a problem arises. The problem is that attackers can get the hash on one machine, and then it can use that hash on all the other machines and gain full administrative access. So it's a bad idea to share a local admin password. Next, we are going to go into the lab environment, and I'm going to demo how a shared administrator password can be abused by an attacker. So here we are in the lab environment, where I'm going to show you how we can compromise one system, dump the hashes for the local accounts, and then try to pass those hashes to other systems to gain access to other systems. And this is only a problem if you have the same password on each system. So that's important to keep in mind. So first, we are going to start by just mapping the local network we are currently in. So I'm going to use crackmap exec for that. And as you can see, there are several systems in this environment. And we are going to do the same with a username and password we found earlier. This could be, of course, either if, let's say, you relayed something and created a computer account, or maybe you found a username and password on a share, or maybe you found it on a printer that didn't have any protection in front of it, or yeah, either way, you found a username, you found a password, and you are trying to figure out what you can use it for. So I'm going to use crackmap exec to spray that username and password across the systems in my local area network and see what happens. So web1 admin was the username, and the password was password, and the domain was trustedsec.int. And as you can see, it worked on 3 different hosts, but there was only on the one host called web1 that we had local administrator permissions. So we are going to do the same towards that one host, and we are going to use the module for dumping the SAM. That's basically dumping all the local accounts and their NTLM hashes. And there we can see that we got the different hashes. So here's the one for administrator account. So we're just going to grab that one, and then we are going to just try WVMI exec from inpacket towards the client one host, just to see if we can access that using the hash we just found. So I'm going to specify work group, since we are going to authenticate locally and not towards the domain. And I'm going to specify the IP address of client 1 and I'm going to type hashes because we want to use a hash, and then I'm typing in the hash. And then we press enter, and we have a shell on that host. So if I type host name, we can see that we are in fact on client 1. And if I type who am I am the local administrator. So as you can see, it's pretty simple for an attacker to move around as long as they have the hash that is the same on each system. So that is how you can grab a hash when the password is the same on various systems and pass it around. So how do we handle a situation where we have a shared local administrator password defined on every host in your environment? There are many ways of handling this. One way could be to define a custom script that visits each host and sets a new unique password and responds back to you as an administrator. Another way, and probably the preferred way, is to use Microsoft's free local administrator password solution, also known as LAPS, to configure this. So the way you do that is you first install a little component on the domain controller, and that component just extends the Active Directory schema to add additional attributes used by LAPS. After you've done that, you need to install a small agent on each host. That's basically just a DLL file. And you also need to define a group policy object that sets the different LAPS settings. And it's basically just a few settings that determines the length of the password and how often it's changed. So after you defined all those things, the Windows host will by itself change the local administrator password, and it will store that password to its own Active Directory computer object inside the LAPS attributes. So that way an admin can look up the password whenever he needs the local admin password. If you cannot change the local admin passwords on each host, another way to handle the abuse of this is to change who is allowed to access this computer from the network and even RDP, and don't allow local accounts that are member of the administrators groups to log in over the network. That way, if someone grabs the hash from one machine, they cannot pass it to another host in the network because you have defined this as a security policy. Next, we will go into the lab environment, where I will demo how we can set up and configure labs, as well as go over how to prevent network logging with local administrator accounts. So here we are inside the lab environment, and we are logged into the domain controller 1. What we are going to do next is we are going to install and configure labs. So we start out by visiting this link here, aka ms/labs. This is where you'll find all things related to labs. Click the download button, and then you choose the appropriate architecture. In my lab, I only have 64 bits operating systems, but if you have a mixture, you need to download the additional ones you need. If you are interested in reading more about the official documentation, I recommend reading the operations guide found here. So there we have the file downloaded. Next, we're going to start the installation. I'm gonna click next. I'm gonna accept the license agreement. And here is probably the most important step when installing on a domain controller. You do not want to install the ADM PVD GPO extension. This is the DLL that will be registered on the hosts. And this is the thing you want to deploy to all computers in your environment that will be using labs afterwards. And this should not be installed on the domain controller. But you want, however, to install the management tools. You want the ADMX templates. That's for adding the group policy settings needed for labs. You also want the PowerShell module. This allows you to update the Active Directory schema as well as delegate permissions needed. The FAT client UI is something we don't necessarily need on a domain controller. It's basically a simple UI for typing in a computer name, and then it will look up the appropriate attribute in Active Directory for that computer to show the password and the expiration time of the password. This is something you typically install on a help desk machine or a terminal server. And now the installation is finished. We're going to start up PowerShell. So first we are going to import the module we installed. It's called admpvd.ps, and this gives us access to some interesting commandlets. The first commandlet we're going to run is the update admpvd AD schema. And to do this, you need to be a member of the schema admins group in Active Directory, or else this will fail. When we run this, it should normally say success as a status entry here, but I've already ran this in the lab ahead of time, so it's stating entry already exists. And you can see that the two attributes it wants to add is the MS-MCS ADM PVD expiration time, as well as the MS-MCS ADM PVD. The MS-MCS ADM PVD is the attribute used to store the password. The MS-MCS ADM PVD expiration time is used to store the expiration time of that password. So whenever the expiration time is exceeded, the password will change automatically. Next, we also need to adjust the permissions in Active Directory, because by default, computers are not allowed to write to these attributes, and we want the machines to be allowed to update their own attributes, especially these two. So what you do is that you run a commandlet called set adm pvd computer self permission, and here you need to specify an identity, and the identity here is the organizational unit where the computers are located in Active Directory. So in my lab, I have computers in this organizational unit called the computers. So I'm going to copy out the distinguished name. I'm going to go back into PowerShell, and I'm going to paste out the distinguished name. I'm going to hit enter, and now we have added the needed self-permissions for computers in that organizational unit. So if we go back to Active Directory, users and computers, and look at the permissions on the computers organization unit, we click on security, we go on advanced. You should see two new self permissions for descendant computer objects. So if we click edit on one of those and take a look in the list here, there should be a check mark right here next to the write MS-MCS ADM PVD. And this ensures that the computer object itself is allowed to write to this attribute. The other self permission is for the other attribute called MS-MCS ADM PVD expiration time. So that's how you verify that. So by default, domain admins are allowed to read these attributes, but sometimes you want to allow help desk groups to read out these passwords for various reasons. So we are going to delegate the permission to a group so that you can add users to a group later on, and they would be allowed to read the password for the computer accounts. So we're going to run a commandlet called set adm pvd read password permission. And just as before, we need to specify an organizational unit. So I'm going to use the same as before. And we also need to specify allowed principals. So in this case, we need to create a group for that exact purpose. So I'm going to create a new group right now called read labs pvd. And then I'm going to copy that name. I'm going to go back to PowerShell. I'm going to paste that in. So if I click enter now, it should all be delegated. So if you add a user to this group, it should now be allowed to read those attributes in Active Directory. Next, to deploy labs, we need to create a group policy that we are going to configure with the appropriate labs settings, as well as deploy the MSI file to all the hosts. But before we do that, we need to copy out the ADMX file to the central repository, since we are using a centrally managed repository of ADMX files for group policies. So I'm going to go into my local C drive on the domain controller in the Windows policy definitions, and I want to copy out the ADM PVD ADMX file, as well as there's a file in here called ADM PVD ADML as well. So I'm gonna copy those over to the central store. So I'm gonna browse into sysvol, trusted sec, policies, policy definitions. I'm gonna place the ADML file here, and I am going to take the ADMX file and place it here. Now we're up to date in the ADMX templates. Next, we are going to also copy over the MSI file. I want to place it here. So I'm gonna do that, copy, paste. The reason I'm doing this is because we are going to create a policy that will go to a central location and install the MSI file. And this has to be a share that all computers can read from. And by default, NetLogon is such a share. It could also be whatever you want, but computers need to be able to read the files inside this folder. Next, we are going to start up the group policy editor. So I'm going to browse in under locations, Norway computers in my scenario, and then I'm going to create a GPO and link it here. I'm going to call this labs, and then we are going to edit this group policy. So first off, we are going to install the MSI file. If you have other deployment solutions, you might use those instead of this, but I prefer to have all labs related stuff in one group policy. So that's why I'm doing this. And then you browse to the share where you just place the MSI file and add it. So the next time the computer reboots, it should now install this MSI file. Next, we need to go in under the admin templates, under the labs settings. And this is where we configure all things related to labs. So first off is the password settings. We want to set this to enabled, and here we can specify the length, or first we need to specify the complexity. I want to have large letters, small letters, and numbers. And the length should be 14 characters, and I'm going to set the password age for 30 days. And I want to enable, and labs will not work unless you set this to enabled. This basically tells it it's okay to change passwords. If you have changed the default setup and you have another admin account defined you want to administrate, you need to specify the name here. By default, it will pick up the administrator account based on the 500 SID. If you are worried that you have a really strict password age policy, let's say you have a password age policy of you have to change every 15 days, and in this example we have set labs to change the password every 30 days. If you enable this setting, it will make sure that the password is changed before the password expiration is hit. So it makes sure that it adheres to the default or the password policy. So I'm going to enable that just to be sure. So that's it. So next thing we're going to look at is we're going to switch over to a computer, reboot it and see that labs is deployed. And then we are going to go back into Active Directory and see that the password is actually stored on the computer object. So here we are on Web 1 in the lab environment, and we are going to just verify that labs is installed correctly when I do a group policy update. So it says that it needs to reboot basically, so we're going to do that. And during the reboot it will install the MSI file and apply the settings. So here we are back into Web 1, and we're going to look in the control panel just to see if Labs shows up as installed. It sure does. So that means the client-side extension is installed. So next we're going to switch to Active Directory, and we are going to look up the local administrator password. So here we are back on the domain controller again, and we are going to verify that Web 1 actually updated its labs attributes. So I'm opening up Web 1, going into the attribute editor, and I'm looking down on the list of attributes, and I can clearly see that the labs attributes has been updated. So this is now the current local administrator password on Web 1, and it will change every 30 days according to our group policy. So that's how you configure labs in an environment. If labs is not a thing you can use for various reasons, there are other countermeasures you can do to prevent pass the hash, and that is deny network login from for the local accounts that are member of the administrator group. So I'm going to show you how to do that, and we are going to create a new group policy, in this case under USA. I'm going to create a GPO and link it here. I'm going to call this prevent pass the hash. I'm going to edit that group policy, and then I'm going to extend policies, Windows settings, security settings, local policies, user right assignment, and then I'm going to change the deny access to this computer from the network. I'm going to define it, add a user or a group, click browse, and I'm going to change from the domain to the local DC, and I'm gonna type local, going to click check, and it will show me some different options here. So the one I'm interested in is the local account and member of administrator group. Click OK, OK, and apply. And as of now, if anyone tries to connect to one of the computers under the USA, and they're trying to use a local account that are a member of the administrator group, they're not allowed to log in over the network. You could also do that for RDP if you'd like, and also many other things. So this is just to show you an example, a countermeasure that is really effective against pass the hash. Another thing we see on engagements is the lack of SMB signing. And by default, Windows does not require SMB traffic to be signed. The only exception is domain controllers. They require SMB signing in order to verify who they're talking to. Since this is not on by default, attackers can perform something called a man-in-the-middle attack and relay connections between resources. So if they get an incoming connection from one machine, they can relay that to another machine and effectively use the hash retrieved from that initial connection and perform actions on the other machine. Next, I'm going to demo how we can, as attackers, relay SMB connections. So here we are in the lab environment, and I'm logged into the Kali attacker machine. First off, before we relay anything, we are going to map out all the different hosts and see if they require or does not require SMB signing. And for that purpose, I'm going to use crackmap exec. And as you can see on this list now, you have signing either true or false. If it's true, it means that the host requires SMB signing to be turned on. And as you can see, most of them are false. The only true we have is the domain controller. So I know for a fact that Web1 is trying to connect to my attacker machine every now and then, because I've placed a shortcut somewhere. So every time an admin visits that share, he tries to connect to my attacker machine. So I'm gonna try to relay those connections from Web1 over to SRV1 and see if I can dump the local hashes on the SRV1 server. And for that, we're going to use in packets NTLM relay X, and we're going to specify the target, and in this case it's 11, and I'm also going to turn on SMB2 support, and I'm running this, and it starts up the different protocols. And as you can see, you can also relay other stuff, not only SMB, but also LDAP, SMTP, and others. Okay, server is started, and in the background now, the Web1 is making a connection towards our attacker machine. And as you can see, we got an incoming connection, and it connected to our target, and it authenticated as the hash it got from the Web1 server, and it saw that the remote registry was stopped, so it started it, and then it dumped the local hashes and exit out. So that's how attackers can relay connections from one host to another. Turning on SMB signing is normally not an issue. However, there are cases where you have SANs or printers or some other operating systems that is not Windows that can be affected by turning this on. So my recommendation is to always test it out in your own environment and try to verify all other equipment than a Windows operating system to make sure that it works with SMB signing turned on. It can also affect performance, since you are now effectively signing all the SMB traffic, which you didn't do before. So it requires some extra CPU cycles, and it can also affect network traffic. But if you turn it on, you are effectively preventing relaying of SMB traffic. So you're stopping man-in-the-middle attacks. Next, I'm going to show you how you can turn on the require SMB signing setting in an environment. So here we are back in the lab environment where I'm logged into DC1, and we are going to create a group policy to require SMB signing. So I'm going to start by creating a new group policy under the locations organizational unit, because this is where I have all my computers and my servers and everything. So I'm creating a GPO and linking it here. I'm going to name this SMB signing, and I'm going to edit that group policy. And then I'm going to navigate to Windows settings, security settings, and the local policies, and then the security options. And now we are trying to find the Microsoft network server, digitally sign communication always. We are setting this to enabled. Yes, we are sure. And we also want to change the network client to always digitally sign communication as well. So there we have it. We have now ensured that if it's a server, it requires SMB signing to be turned on. If it is a client connecting to a server, it also requires SMB signing to be turned on. Another thing we see a lot is the printer bug, also known as the SpoolSample. What this basically is a built-in thing in Windows or the print spooler that allows you to print a job to a server, and you can then tell the server during the print job that it should send a notification when it's done to your host system. The thing is that the RPC interface that is used allows you to specify whatever host you want, meaning that you can get the remote server to connect to a system of your choosing. The attacker though needs to be authenticated, meaning that you need to provide a username and password for this to work. In the best cases for the attacker, it can result in getting the net NTLM version 1 hash if the server is older than 2016 or older, or the client OS is older than Windows 10. The net NTLM version 1 hash can be cracked within seconds using a rainbow table. And you can then use the hash you retrieve from that to generate a ticket that you can use to authenticate. For this to happen, the network security LAN manager authentication level needs to be set to send NTLM responses only. There are also other options below that are less secure, but for net NTLM version 1, it needs to be set to that or lower. Next, I'm going to show you how the attackers trigger the printer bug, and also how to retrieve the net NTLM version 1 hash. So here we are on the attacker machine in the lab, and we are going to try to trigger the printer bug. So first off, we need to start responder, and we are going to try to do the LM downgrade option in responder. So first I need to specify the interface and then --LM. And I can see that the force LM downgrade option is turned to on, and I can verify that this is the correct interface and IP address. Next, we are going to use the printer bug PyScript in the KRB Relay X toolkit provided by Dirk-Jan. So we're going to type Python 3 printer bug, and then we are going to specify a user because we need to authenticate. So I'm going to use IT-admin in this case with the password of password, and we are connecting to an old 2012 R2 server, and we want to connect to it, and we want the RPC call to make it connect back to our attacker machine that is located on .44. Try to run the script, and it seems that something happened, and if we look back into the responder, we can see that we were able to capture the NTLM version 1 hash from the server itself. So this means we could send this to a rainbow table cracker, and we should be able to get the hash within seconds, and then we could use, for instance, in packets ticketer to generate a ticket that we can use to authenticate as the server itself. That's how attackers trigger the printer bug. So how do we fix the printer bug? How do we prevent attackers from abusing this? The easiest way is to disable the print spooler service on all the systems that doesn't need it. It's in many cases an unnecessary service. The bug is fixed in the newest versions of Windows Server and Windows Client, so upgrading is also an option. Now I'm going to show you how to disable the print spooler using a group policy. So here we are logged into the domain controller, and we are going to create a group policy to disable the print spooler service on several computers. So first off, I'm gonna target the computers organizational units because this is where I have all my servers and computers. So I'm going to create and link a GPO here. I'm going to call this disable print spooler. And then I'm going to edit this group policy. And then I'm going to expand Windows settings. Go to security settings. And then go down into system services. And then you can find the service you want to disable, in this case, the print spooler. I'm going to define this policy and I'm going to set this to disabled. Click apply, hit OK. And from this moment on, the print spooler service should be disabled on the next group policy update. Next, we are going to look at name resolution in Windows and how that is abused by attackers. So Windows has a standard way of resolving names into IP addresses. And when Windows is communicating with another host, it uses the IP address. So when you try to resolve a name, it first checks if the name belongs to himself. If that is not the case, it checks the local host file. And if no match is found in the local host file, it queries the DNS servers. If no positive response is given by the DNS servers, it starts to broadcast. So this is the part that is interesting for attackers, because as an attacker, you can actually respond to these broadcasts and make the machine that is trying to resolve the name connect to your attacker machine. So it tries first by using something called the link local multicast name resolution. It's also known as LLMNR. If that doesn't provide any answer in the local area network when it broadcasts, it tries something called NetBIOS Name Service, NBNS. So as an attacker, you can poison both these broadcast techniques. As mentioned in the previous slide, LLMNR and NBNS broadcasts can be poisoned, and one of the most known tools for doing this is Responder. The tool will attempt to answer these broadcasts, and if the computer tries to initiate a communication afterwards, it attempts to capture either the plaintext password or the password hash. In many cases, especially in Windows environments, this is typically the NetNTLM version 2 hash. Attackers can then try to either relay the hash to another host to gain access that way, or they can capture the hash and then try to crack the hash offline. That way they would get the plain text password for that account. WPAD is the Web Proxy Auto Discovery Protocol. And this is something that is used by the web browsers to figure out how to set their proxy settings. And it can be configured in an automatic way. So when a web browser opens or queries for proxy information, it first asks the DHCP server for information. So as a sysadmin, you can configure the DHCP server to provide the needed information. If that isn't configured, the protocol tries to connect to various URLs, leading to DNS queries. If none of those resolve in anything, it starts to broadcast in the LAN, meaning that you will see LLMNR and NBNS broadcasts for the WPAD record. So as an attacker, you can basically provide a response to the query for WPAD and make the computer connect to your host, and you can provide proxy settings if you want to and become man in the middle. Next, we're going to head into the lab environment, where I will show you how we can use Responder to poison NBNS and LLMNR broadcast messages, so we can effectively capture a NetNTLM version 2 hash from a user. So here we are in the lab environment, and we are going to start up Responder to respond to any broadcasts in the network, so we could possibly capture a hash. So I'm just going to start up Responder without any options. I'm just going to specify the interface so it listens and responds to broadcast messages. And now it's running, it's listening for events. So to speed things up, we are going to head over to the main controller, and we are going to falsely connect to something that doesn't exist. So here we are on the domain controller, and let's pretend that we are a sysadmin and we want to connect to another DC, and we for some reason mistype it. We were supposed to write DC2, but instead we typed DC3. I hit enter. Oh, nothing happens. In the background now, this server will try to broadcast for DC3, since it doesn't resolve in DNS and all that stuff. And on our attacker machine, we are capturing the hash. So if we turn back to our attacker server, we can clearly see that connections were made and that we were successfully in capturing net NTLM version 2 hash. And this hash can be cracked with hashcat, for instance. And that way you can get the plain text password and you will have credentials in the network. So how do we fix this issue with broadcasts? Well, there are ways to disable both LLMNR and NBNS. And to disable LLMNR, it's pretty easy because it's basically just setting a group policy setting and it's turned off. When it comes to disabling the NBNS broadcasts, it requires a little more research and work. So you could either specify a DHCP option to disable it, or more normally you define a script that runs at computer startup. Normally, disabling these protocols should not affect anything, but as always, it's recommended that you test in your own environment prior to just releasing it to the production environment. And there could also be legacy applications and systems that are depending on these broadcast techniques. So just be aware that it might affect things. So test first. When it comes to WPAD, it can have an impact when you disable it. It depends on how you use it in your environment. Maybe you are depending on that function and you cannot disable it. One of the issues I have seen when disabling WPAD is when you have people traveling the globe and they need to use a public Wi-Fi to connect, because public Wi-Fi's often redirect the clients to a capture portal using the WPAD function. And since you then have disabled that, the user will never see the actual portal to log into the Wi-Fi. To disable WPAD, you could either disable the WinHTTP auto proxy SVC service, or you can set a group policy preference to disable the use of WPAD. In the upcoming lab, I'm going to show you how to do it using the group policy preferences way. And now we are going to go into the lab environment, where I will show you how we can disable NBNS, LLMNR, and also WPAD. So here we are in the lab environment, and first I want to go over how we can disable LLMNR. So we are starting with just going into the group policy management, where we are going to create a new group policy, and we are going to call it disable broadcasts. And then we are going to edit that group policy. And then we are going to navigate into computer configuration, policies, administrative templates. And then we are going in under network. Then we are going to DNS client. And here we need to look at the setting called turn off multicast name resolution. So if you open up that setting, we should set this setting to enabled. If we set this setting to enabled, we effectively turn off LLMNR. That's it. So that's how you set up and disable LLMNR. So let us look into how NBNS is configured on a system. So to first show you how or where this setting lives, we can open up the network adapter for just this server, just to show you where it lives. So I'm opening up properties, and then I'm going into the TCP IP version 4. And under the Advanced tab, we have something called VINs. And as you can see, here are the NetBIOS settings. And by default in Windows, it's set to default. And it says here that it's going to use the settings from the DHCP server. And if nothing is provided, it will be set to enable NetBIOS over TCP/IP, meaning that it will be enabled unless something from the DHCP server configures to do something else. So there are two or several methods of disabling this. You could manually just set disable on all machines, but that's not possible in a big network. So first I'm going to show you how you can do this with DHCP server. In this example, I have just created a dummy scope. It's not enabled, it's not doing anything. I just want to show the options. So on the scope where you want to disable NBNS, you go to Scope Options, Configure Options. Under the Advanced tab, you need to browse and find the Microsoft Windows 2000 options. And here you have an option called Microsoft Disable NetBIOS option. You need to turn that on. Then you need to configure this with the value of 0x2 and click Apply. So this will make sure that if a client gets an IP address from this DHCP server, it will set the NetBIOS part to disabled. If configuring this with DHCP is not an option for you, there are other methods of disabling it. The other option I want to show you is how you can use a simple script to just deploy that at computer startup and disable the setting. So let's go back to our group policy and let's create our computer startup script. So in the same group policy, I'm going to browse under the Windows settings, under the script option, click on the startup, go to the PowerShell scripts tab, and then click on show files. Right click, new, I choose text document and just call this disable NetBIOS. And of course we need to make sure that we can see the extension because it needs to be a PS1 file. And then we edit it. And I prepared a simple script like this. So I'll explain it. So first it sets the variable reg key to this path here. This is where all the interfaces live. And then I do a get child item on the interfaces. So I enumerate all the interfaces. And then for each of the interfaces, I set the option NetBIOS option to value of 2. That's it. So saving this, closing the editor, going back to the group policy, click on the add, click on the browse, click on the script file, click open, click OK. And here are some options if you want to run scripts in specific order. Doesn't really matter for what I'm showing you, but make sure to select the ones that fit your environment. Then you click apply, click OK, and the next time the computer picks up this group policy, it will run the script at startup and disable NetBIOS for all the interfaces. So that's the second option. So the third thing I want to go over is how we can disable the WPAD setting. So this is normally a user setting. So what you normally would do is create something called a group policy preference. So navigate under the user configuration, preferences, control panel settings, then go into internet settings, create a new setting option. I'm going to choose Internet Explorer 10. And here is a thing to be aware of in terms of group policy preferences. You can see all the lines here are marked green. These are controlled by the F5, F6, F7 and F8 on the keyboard. So if I press F8, they become red and they are not going to be configured.
And I only want to configure one thing and not everything in Internet Explorer. So that's important to visit each of these tabs and disable the settings, so you don't set them to what is set in this group policy. So I'm going to do that for all the options. There we go. Security. There we go. And I'm going to go here. Also here and here. And let's see, there's couple more here and here as well. Okay, and here is the interesting part in terms of WPAD. So you go into the LAN settings, and the setting here is the setting that actually decides if WPAD is going to be used or not by the computer. So if you set this to not enabled, it will not try to get the WPAD settings. You have to make sure that this line is green though. So I'm gonna click it and press F6 on the keyboard, and you can see it's set to green, meaning that this setting will be configured as part of the group policy. Press OK, click apply, click OK. And the next time the user logs on, the WPAD should get disabled. So that is how you configure and disable LLMNR and NBNS and WPAD.